As we have discussed that about the suspensions and colloids, and let's understand some of the examples of suspensions and colloids. Let's see. So suspensions, the solid particles are bigger in size and which is dispersed in a liquid medium. Okay, we can see with our naked eye that is a major characteristic feature of solid particles in a suspension. Okay, so let's see what are the best examples of these suspensions. Chalk powder in water, muddy water. As when you add the muddy particles in the water, that looks like and appear like this suspension, because muddy particles are big and you can see with our naked eye. And sand particles, sand in water is also the best example of the suspensions. Now, milk of magnesia. Normally milk of magnesia is used in the digestion process here. That's also, as magnesia added in the milk looks like a suspension, as magnesia never dissolved in the milk. So as it is called as the suspension. Now let's understand some more examples of the colloids. Right? Colloids, as when compared to the suspensions, colloids, the particles are smaller. So dispersion phase and dispersion medium. So what is dispersion phase? Dispersion phase is nothing but the particles which is dispersed in a media, the liquid particle. The adding particle is called as the dispersion phase, and the receiving where we are adding, that is called as the dispersion media. Okay, so ink, soap solution and paints are the best example. You can see here solid in liquid. So solid in liquid. So dispersion colloids will be solid in liquid, or liquid in gas, or liquid in liquid, or gas in liquid, maybe any type. Okay, we don't say that only always. It is not possible to say that all solid in liquid. Okay, in colloids it is not at all possible. Now let's see here colloids are the best examples. The best examples of the colloids here: solid in liquid solution, right? Ink and soap solution and the paints and the colored gemstones. Normally we use in for the ornamental purpose for ring. We use it for the ring here. Colored gemstones. Okay. Next, colored gemstones are prepared by solid in liquid. So now let's see here. Liquid in gas. What is the best example of liquid in gas? As we see that evaporated water droplets in the atmosphere, that says that mist. Water droplets in the atmosphere is called as a mist. And fog. What is the fog? Fog is also the smoke, gaseous particles which is present in the atmosphere. That is called the liquid in gas. Hair sprays. You know that hair sprays. And clouds. Clouds also the best example of the liquids in gases. Air is a gas. These clouds are the liquids. In such manner that it is called as the liquid in gas. It is the best example of the colloids. Next, liquid in liquid. What are the best examples of the liquid in liquid? Milk, right? Butter are the best examples of liquid in liquid here. And gas in liquid. Shaving cream. In that gas is added. So because of addition of the gas in the liquid, as it is blowing out. As it is what? Blowing out. Hair gel is also the best examples of the colloids. You have to remember that colloids. So two phases are there in the substance which is adding out from the outside, that is called as the dispersion phase, and where we are adding, that is called as the dispersion medium. Right? Now let's understand the separating the components of mixture. So let's understand the separation of the components of mixture. As we discussed that suspensions and colloids are the best examples of heterogeneous mixtures. They are not the homogeneous. Colloids looks like homogeneous, but it is heterogeneous. Okay, heterogeneous mixture can be separated by hand pick or sieving. Sieving means filtering. Normally we use the tubes to separate that. Sieving and filtration. These are the best examples that to day-to-day life. So in day-to-day life, we use the different types of techniques that to separate the substances. Now here let's discuss one of the best technique that to separation technique here. Now generally separation technique, why this separation technique? So colloids can be separated. or suspensions can be separated. Now we are seeing that ink is a suspension. Ink is in suspension or colloid, you may anything. Heterogeneous mixture. Ink, you know that pen ink. The ink which is present in this what is made up of heterogeneous mixtures, heterogeneous substances. It is made up of heterogeneous substances here. So let us see that. What is the aim? How we are going to separate this ink, pure ink, pigment. The colored pigment is separated from the ink by using different techniques here, different separation technique. Now let me explain that what is the different technique or the separation technique that we are going to use in the separation of the dye from blue or red ink. Okay, so what is the aim? What is the aim of the experiment? That how can we obtain colored component dye? How can we obtain colored component dye from blue or black ink? Okay, let's see that. So what are the requirements? This is the aim. How can we obtain colored component dye from blue or black ink? Now let's see the requirements. What are the best requirements here? You see, beaker, water, and Bunsen burner. So let's start burning this. Switch on the fan. As the heat reaches from the Bunsen burner to the glassware, that which is where water is added, beaker. So slowly water gets heated, and upon the surface of the glass beaker, we are going to place the watch glass. In watch glass, what is this? Ink, red ink or blue ink. You can take slowly. When you goes on heating, that the vapors from the water reaches this glass, reaches this watch glass, and the watch glasses get heated. Direct exposure of ink to the fire. What happened? The ink may be dry up. The ink may be dry up. As direct exposure to heat, that it may dry up. So to avoid the drying up directly here, so we are using this technique. So what is the content? So ink is made up of alcoholic substances and pigments. Ink is made up of what? Alcoholic substances and dye, pigment substances here. Ink is made up of alcoholic substances and dye substances. It means pigment substances. It is a mixture of alcohol and pigment substances. Now we can separate this. We can separate this by heating. As we travel from the Bunsen burner to the water, from the water it is going to turn up. It reaches the watch glass. As watch glass is going to heat. So because of heating, then what happened? As the ink is made up of volatile and non-volatile substance. What is volatile? The substances which have capable to evaporate very fastly. Which can evaporate very fastly, as petrol is evaporating substance. It is with normal heat only it evaporates. Okay, when you place the petrol in a bottle outside for 24 hours, the next day morning you cannot see the petrol because it is highly volatile. It escapes very fastly. It evaporates very fastly. So in the same way, on heating, the volatile substances present in this ink is evaporated. The volatile substance present in this ink is evaporated very fastly. So because of this evaporation of the volatile substances, as a non-volatile ink substance remain there. So it is nothing but on heating, by process of evaporation technique, we are separating ink from the volatile substance. What is the volatile substance here? Alcohol. That is the main observation. What is the observation? As in the form of vapor, alcoholic volatile substances is evaporated. By the evaporation technique, volatile is separated from non-volatile substances. That is the main content you have to understand. This non-volatile substance is now free and pure. Without any mixture. Now it became homogeneous mixture. Conversion of heterogeneous to homogeneous. That is called as filtration. Separation technique. Okay, that is the main content behind this. This is another technique, separation technique. This is another separation technique. Now let's understand. In previous topic we discussed about the separation technique by evaporation. But here we are using another technique, that is centrifugation. What is centrifugation? Centrifugation is a separation technique that based on the principle as the centrifuge rotates with some certain speed. The centrifuge is a machine that which rotate the tube with certain speed. When it is rotated with certain speed, the denser particles will reach to the bottom and light particles will be on the surface top. So based on it follow the particular way that the lighter particles on the top and denser particles will reach the bottom. Even you have seen the blood test. So even blood test is also done by using this technique. As to separate the denser particle and lighter particle in your blood, they use the centrifugation technique. As we cannot find this in a school level laboratories, we will find this in college level laboratories like post graduation. In your higher classes, that whatever the higher classes you select, that depends. Okay, in chemistry and biology and physical departments also we see that. So based on the concept and the principle of density, the particles reach the bottom, the denser particle reach the bottom and the lighter particles will be on the surface. So here we are taking, right, in the centrifugation technique, we are taking the sample of milk. We are taking the sample of milk. As we take the milk and separate, as nowadays we are getting full cream milk. Full cream milk, that is Tetra Pak. Full cream milk is nothing but 9% fat, 10% fat, 6% fat. So like the different amount of the fat we are getting. So we can separate that fat. We can separate that fat amount from the milk. So how can fatty substance is what? Which is a suspension particle, which is suspended particles. Okay, we can also call colloid or suspended heterogeneous mixture. It is what? Heterogeneous mixture. Milk is a heterogeneous mixture. As we cannot see, its surface look like homogeneous, but it is heterogeneous mixture. Now let's see here. In this milk content, we will see that fatty substances are present. As we cannot, when you cannot find centrifuge, you can also do this activity in your home. Right? How can you do this? You can take, add the milk in the bowl, and usually in your kitchen you will find the churner. When you churn the milk for longer time, that you will find that the solid particle, the heavyweight particles will stick to the churner. By that, milk light particles will not stick to the churner, and the heavyweight and denser particles will stick to the churner. By the technique, it is also kitchen centrifuge. We call it as a kitchen centrifuge. Okay, natural centrifuge that which is available in the kitchen. So we can say that kitchen is the greatest center for separation techniques by this example. So this is the major thing then. What is the concept and the principle involved in this activity? Centrifugation technique. What is it? Centrifugation technique. Okay, right. So now let's understand another example. Let's understand another example. Okay. Now, how can we separate a mixture of two immiscible liquids? Two immiscible liquids mean the liquid that which cannot dissolve in other liquid. That is called as immiscible liquids. Miscible liquids mean the liquid one which dissolves in other liquid, that is called as miscible liquids. Now let's understand that. So the aim of the experiment, how can we separate a mixture of two immiscible liquids? So here two immiscible liquids are kerosene and water, or petrol and water. Let's see. So to separate this technique, here you have to take a beaker, big beaker, and add kerosene and also in the water, and it goes on stirring. As the kerosene and water, right, mix each other but cannot dissolve, cannot compatible. Okay, so in such case that, so how can we separate this kerosene and water technique from this beaker? So the major concept of this activity and the experiment is that how to separate the kerosene and water. The kerosene and water are two immiscible liquids that can be separated by using a separation technique. Let's see that. We are using this separating funnel that to separate the kerosene and water. Water have more density than when compared to the kerosene. So normally when ships are traveling, in the seas and oceans, some amount of the petrol or diesel or kerosene will leak out from the ship tanks or whatever it may be. So that leak outs will float on the surface. What is the reason that oil float on the surface? Because the density of the liquid is very less when compared to the water. That is the reason why kerosene cannot go inside when in case of the water. So in the same way, we have mixed here kerosene and water, right? The quantity of the kerosene and water you can pour into this separating funnel as when you pour, right? So in a minute of time, the water quantity will settle down because the water substance density is more when compared to the kerosene. So what happened? The kerosene will settle on the surface of water and water will settle at the bottom of the separating funnel. What is the reason? The reason is that density, based on density of kerosene oil and water. So water will move down, right? Because of its higher density. Now open the stopcock. When you open the stopcock, water will move down, right? Water will move down first because of the density that it reaches the bottom. You can separate water in one container, right? You can separate water in one container, and also you can separate kerosene in one container. So due to that, so this is the technique that we are following, that separating funnel, right? We are following the density technique that to separate the water and the kerosene. This is one of the important technique that to separate the two immiscible liquids. Now let's see that what are the major applications of this separation technique. Oil and water can be separated by this technique, right? And even in the extraction of iron ore is present in the molten form. As the slag will be on the surface of the molten and iron ore molten at the bottom, because iron ore molten is having higher density when compared to the slag. So by using this technique in the furnace we pour the ore. So based on the density only, right, the iron particle reaches down from the molten. The higher lighter particles are present on the surface of the furnace. This is the technique that we follow. So, okay, the major importance of this technique is that to separate the two immiscible liquids.